Okay, so for this lecture, this is over the mass mole conversion worksheets. We're in chemistry, chapter 5B. And for this lecture, you're going to want to have a periodic table handy, a calculator handy, and we're going to do 4 problems from the mass mole conversion worksheet number 1. And then 1 problem from the mass mole conversion worksheet number 2. So if you need to pause the video and gather all those materials, go ahead and do that. So at the top of your worksheet, I want you to write this formula. So let's go ahead and get this out of the way. Write atoms / molecules, and then a double arrow to moles, and then a double arrow to grams. So this is our procedure to convert atoms to moles, moles to grams, and the reverse, grams to moles, and then moles to atoms or molecules. And we want to remember that 1 mole of anything is equal to 6.02 times 10 to the 23rd. All right, so that's going to be, in chemistry, we're talking about atoms or molecules. So that number, when we put our conversions together, 6.02 times 10 to the 23rd will always be beside the word atoms or molecules. So let's look at your worksheet. The first one I'm going to work is 3A. Okay, 3A. And 3A says how many moles are in 3.24 times 10 to the 27th atoms of uranium. Okay, so let's write down what we know from the problem. 3.24 times 10 to the 27 atoms of uranium. We'll put that over 1. So we want to convert that to moles of uranium. And what we're going to get rid of or cancel out, just look up and to the left, is atoms of uranium. Now, how did I know we just go to moles? Well, you start with this process. We've been given atoms. We want to go to moles. So since we're just going over from atoms to moles, going over one section in our formula, then we just have 2 sets of parentheses. All right, the 1 always goes by the mole. Anytime it's mole and anything else, whether it's moles and grams, moles and atoms, the 1 always goes by the moles. How many atoms are in a mole? Well, this is a number you got to memorize, but at 6.02 times 10 to the 23rd atoms in a mole. So in your calculator, I don't know if you can see this, but hopefully you can at least listen to me do it. So it's 3.24, and then don't do times 10, hit the second function button and then the double E. It may be in a different spot if you have a TI 84, but you're looking for the double E button. So mine says 3.24E and then 27. That's the same thing as times 10 to the 27. Now, since 6.02 times 10 to the 23rd is on bottom, then we divide. So divided by 6.02, second function, double E, 23rd. All right, and if you do that, you'll get 5,382 moles. And that's uranium. Okay, remember, you don't put times 10 in your calculator, just use that double E button and give that a try and make sure that you can do that in your calculator. So that's example 3A. I think I can fit example 4A on this board. So 4A says how many atoms are in 2.56 moles of selenium? All right, 2.56 moles of selenium. Put that over 1. Well, we're starting here at moles. We're just going over one space to atoms. Okay, so I'm just going to have 2 parentheses. So let's put atoms on top because that's what we're going to. And we're getting rid of or canceling out moles of selenium. Okay, if you forget what goes on bottom, just go up to the left. It's that thing, so it'll cancel out. 1 always goes by the mole. And there's 6.02 times 10 to the 23rd atoms in a mole. All right, so since the 6.02 times 10 to the 23rd is on top, this time we're going to multiply. All right, so it's 2.56 times 6.02, second function, double E to the 23rd. All right, and that is 1.54 times 10 to the 24th atoms. Okay, it'll say E in your calculator. If you want to write E instead of times 10, that's fine. Your college professor may not accept that though, so I prefer my students to write times 10 even though you put E in the calculator. So that's going to be atoms of selenium. All right, so there's a couple of examples where we're just doing 2 sets of parentheses. All right, let's do a couple of examples where we're going 3 sets of parentheses. All right, so I'm going to erase this. And let's do, so it's on the back of your worksheet. Let's do 5A. All right, 5A says, what is the mass in grams of 5.22 times 10 to the 19th atoms of plutonium? All right, so start on the far left of your paper. Now, we want mass in grams. We're all the way here at atoms. That's where we started. We've got to go through moles to get to grams. So I'm going to have 1, 2, 3 sets of parentheses. Okay, so we're going to moles of plutonium. Getting rid of atoms of plutonium. The 1 always goes by the mole. How many atoms are in a mole? 6.02 times 10 to the 23rd. Don't forget that 10 to the 23rd part. Now we've got moles of plutonium because the atoms have canceled out, right? And now we can go to grams of plutonium. What do we want to get rid of? Well, we've changed it to moles, so now we get rid of moles of plutonium. Okay, if you forget what goes on bottom, again, up and to the left. So now we have moles. The 1 always goes by the mole. How many grams of plutonium are in a mole? Well, you have to consult the periodic table. All right, so plutonium is here number 94. And it says, if you look at the molecular mass, there's 244 grams of plutonium in a mole. Okay, so in your calculator, we start with 5.22, hit the second function double E button to the 19th. Divide that, since it's on bottom, 6.02, second function double E to the 23rd. All right, and then we're going to multiply that number, since it's on top, multiply times 244. So that is 0.02 grams of plutonium. All right, so that's a lot of atoms, 5.22 times 10 to the 19th, but Atoms are really small, so even a large number like that doesn't weigh very much. All right, and then the last one I want to do for you on worksheet 1, before I go to worksheet 2, is 6A. All right, 6A says, how many atoms are in 59.22 grams of magnesium? So put what you've been given over 1. We're starting at grams. We want to go to atoms. How many atoms? We have to go through moles. So you do have to memorize this process. All right, so let's go to moles first, and then we'll go to atoms. So we'll go to moles of magnesium. We're going to get rid of grams of magnesium. All right, the 1 always goes by the mole. How many grams of magnesium is in a mole? Well, it's not 6.02 times 10 to the 23rd. That number's always going to have atoms or molecules beside it. This is grams. The number that's going to have grams beside it when you're comparing to moles is the number from the periodic table, magnesium, okay? Number 12. There's 24.3 grams in a mole. Okay, you can, on the periodic table, you can round to the nearest tenth. Okay, now we've gotten to moles, we're going to atoms. So atoms of magnesium. Getting rid of moles of magnesium. 1 always goes by the mole. How many atoms are in a mole? 6.02 times 10 to the 23rd. All right, so in the calculator, take 59.22. Divide that by 24.3. And then since 6.02 times 10 to the 23rd is on top, so times 6.02, second function double e to the 23rd. And you will get 1.47 times 10 to the 24th atoms. All right, it's going to be a lot of atoms because we have more than a mole of grams. Okay, so those are 4 examples from worksheet 1. Those 4 examples should be enough for you to work all the rest of the problems on mass mole worksheet number 1. Now I'm going to work mass mole worksheet number 2 is basically exactly like number 1 with one exception. You have compounds instead of single elements. So we're going to have to add up the molecular weight from the periodic table every time. So I really only need to work one of these for you. So if you'll get out worksheet number 2, all right, pause the video, of course, at any time if you need to. Let's work number 6 from worksheet number 2. It says how many molecules are in 218 grams of glucose, so C6H12O6. So what we're going to have to do to answer this is we are going to have to add up the number of grams in a mole of glucose. So for C6H12O6, for carbon, we have 6 of those. Each carbon weighs, if you look at the periodic table, 12. So that's 72. For hydrogen, we have 12 in this molecule. Each hydrogen weighs 1. All right, just look at the periodic table. You can round that 1.01 for hydrogen to 1. So 12 atoms times 1 is 12. For oxygen, we have 6 atoms. Each oxygen, look at the periodic table, 16. So that is 96 for oxygen. Add up the molecular weight. So that's going to be 0, 1, 8, 9, and 9, 18. 180 grams per mole. That's the molecular weight, molar mass of glucose. All right, so we're going back to the problem. We are at grams. We need to go to moles first before we can go to molecules. So let's put moles of C6H12O6 on top. We're getting rid of grams of C6H12O6. 1 always goes by the mole. How many grams of glucose is in 1 mole? Well, you just figured it out. It's 180. So now we are at moles. Grams have canceled out. Now we can go to molecules. All right, this is a molecule, not just a single atom. So we'll just abbreviate that molec. All right, molecules of C6H12O6. And we're getting rid of moles, C6H12O6. The 1 always goes by the mole. So the moles will cancel out, and the only one you don't have a mark through, because everything has canceled out, is molecules. How many molecules are in a mole? 6.02 times 10 to the 23rd. All right, kind of run out of room. So this one example, if you will go by the examples on worksheet 1, the only difference between worksheet 2 and worksheet 1 is in worksheet 2 you have to add up the molar masses, the molecular weights, okay, using the periodic table. You can't just, because you're not looking at a single atom. So in our calculator, 218 on top, so 218, 180 is on bottom, so divide that by 180, and then multiply that number by 6.02, second function double E, 6.02 times 10. Don't put the times 10 in your calculator, second function double E to the 23rd. Let's try it again. And that's, excuse me, try that again. So we started out with, got an error. 218 divided by 180, and then times 6.02 times 10 to the 23rd. Okay, that's 4.07 times 10 to the 24th. And that's going to be molecules of C6H12O6. You don't have to write the C6H12O6, but I'll do it there. Okay, so now you have everything you need to do worksheets 1 and 2 for mass mole conversions. And I will talk to you next video.